Hello, everyone. Oh, come on. Try that again. Hello, everyone. Good morning. Welcome. Happy to see you, 8:30 a.m., right after the parties of last night, which I missed. OK, we're going to start with a Mad Lib, and I'll need your help. So can we get how many of you guys have done Mad Libs before? OK, so the general idea is I ask for a type of word, and then you give it back to me. So adjective. Tall. Burly. I like burly. Medical diagnostic, like X-ray or mammogram or a CT scan. Adjective. Can you see me? No. OK. They usually give us a box for the short people. Adjective? What? Churlish. Sport? Racquetball. And one more. Contact sport. Curling. Human organ. Sport, we want to put in a gerund, like running or something. Boxing. UI interaction? Household appliance. Sorry? Espresso machine, OK. I think my hearing is only on one side. UI element? Ribbon. Do we have a ribbon? We have a ribbon. You second UI element. An accordion? Oh, an accordion control, right, OK. So you're going to have to help me. Hello, everyone. We're here today to talk about advanced profiling and performance techniques in Silverlight. And the first one is Silverlight 4 has profiling tools for your managed and user code, which is excellent. It has been something that has been requested for so long. And then the second thing is we're going to talk about the hardware pipelines. As far as I can see, there's not a lot of documentation about it. People are asking a lot of questions. And I get applications where they set cache mode everywhere, or they set cache mode nowhere. So I'm going to empower you guys to leverage the GPU in your application. So let's start it off. Writing a burly application or component in any platform is similar to keeping tabs on one's health. When you reach the point at which you are taking CT scans, it means that you could have just been a bit more churlish when playing either racquetball or curling. We can look at the system at different levels. We can monitor our brain, and while boxing, or our frame rate while double-clicking. We could find that we are more stressed when an espresso machine is running in the background, or if a ribbon is overlaying an accordion control. This morning, we will share the tools for diagnosing aspects of your application, and you will find that the best expert for actually making your application fast is you. So let's try that again with some more sensical words. So making your application fast is similar to like asking, why does my head hurt? Or what's going on with my blood sugar level? Most of the times, you could take a proactive stance on your medical health, or you could take a proactive stance on being more careful while playing racquetball or curling. You don't have to actually get to the X-ray before you realize that you could have done a better job of keeping tabs on your performance, translating back and forth. So profiling is similar to going to the doctor and asking for a little bit of help on how to make yourself healthier. And so we're going to start with 4 or 5 different tools that we have for measuring and profiling your application in different aspects. So the first step is generally to identify the problem area. If you're a patient, it would be like, my head hurts, or I can't see any longer. For Silverlight, it would be something like, what's the issue here? Are you concerned about the startup? Are you talking about the frame rate when you're scrolling? What do you mean by your application is slow? And then you want to actually monitor the changes as they come in. This is a proactive stance of medicine or of your profiling of your application. In the same way that you can either proactively keep tabs on your health or you can wait until you get a concussion. So the big thing for an example would be on frame rate, you want to make sure that the size of your dirty regions, the size that you're invalidating of your application every frame is quite small or as small as possible. And we'll try to do a good job, but it's also up to you to figure out how frequently we have to draw and how much we have to draw. And then, of course, I suggest always proactively testing on a range of hardware. So one of the first things that you can always do is to verify that things are as expected. The way to think about it is the user can see the application, but often the performance problems are somewhat hidden in the background. And you need a considerable number of tools to figure out what's going on. So one tool that we use is called UI Spy. How many of you guys have used UI Spy on some other .NET platform? OK. So UI Spy allows you to take a look inside the application and see what the visual tree looks like. So how many of you guys have used a virtualizing list box? OK, quite a few numbers. And how many of you guys have verified that it's actually virtualized? OK. So I built a list box the other day, and I thought that virtualization was broken. They said, no, 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 that's user error. So the first way that you can create a list box to virtualize it is to take an items collection and bind it to a list box. And so what happens is the items control generator will kick in and create a visual tree by applying the data template to each of the data items in that item source. So that's basically this model. So you have your list box. It's bound to an item source that's a static resource called names. Off screen, there you go. And then we have an item template that basically puts a stack panel with a button and 2 text blocks. And so what this happens behind the scene is the virtualizing stack panel says, because the virtualizing stack panel is the items panel in the default list box template, the virtualizing stack panel says, hey, items control generator, I don't actually need everything. Just give me the first top 10, and then you can be on your way. And items control generator says, OK, here you go. And so if you pop up UI Spy, which you have to run as an admin, let's see. And I click here, and I wait. And by the way, I'm in mode and hovering. So if I press Control and I click, then I see the UI tree of where I clicked. You'll see that we have all of the data items, but we only have the visual tree of the items that are visible. So you see that there are only so many items that have a visual tree, the first top 10. If I scroll down, virtualizing stack panel then says, hey, can you give me the next 10 items, but don't bother throwing away the visual tree. It's the same data template. Could you just reuse or container recycle the existing items? So if I can control click here, you'll see that the items on top are now virtualized, except for the ones that are not garbage collected yet. Ignore that. And we've reused these 10 items, and we've only built those 10 items that are visible now. And as I scroll, you can see that actually I have a pretty fast frame rate. It's a pretty smooth experience. We're doing all that container recycling behind the scenes. This is what I did when I first built my application. Is the other way to build a list box is to do something like explicitly create them in XAML. List box item, stack, panel, button, text block. So I explicitly created everything. And what's happening behind the scenes is the parser says, OK, I'm going to create this visual tree, and I'll just create these items too. And there are 100 items, and it generates them all. Notice that virtualizing stack panel isn't involved. Items control generator isn't involved either. So there's no virtualization happening. And the way to verify this is right here. So if I pick up UI Spy and I click on this control, we start off with only the list items that are visible. But if let's see, I'm going to page down because I can't see my scroll bar. You'll notice that we're creating the list items, the visual tree for all the list items that have been viewed thus far. And they never contain a recycle and it never virtualizes. So the first trick for profiling is to make sure that you're actually getting the capabilities of the controls as expected. So verify that you're actually getting virtualization. Verify that you're actually getting data grid, and you'll be a little bit happier along the way. So your patient has walked in, and basically now you know its height and width of the tree. And so now you actually generally want to do a little bit of stress testing. You're going to do some little functionality. OK, we're going to go do a marathon, so let's measure our heart rate while we're running, or our speed while we're running. In the same way, you can also do the frame rate, the heartbeat of the application is called the frame rate. And Silverlight is a time-based system. And the best way to explain this is sort of like you have a film strip. And let's say that you're at the second frame. And our default is 60 frames per second, which translates to 33 milliseconds. So if I'm at the second frame, 33 milliseconds, and let's say I get busy for a while, the UI thread is doing something else, and I miss 3 frames. On a frame-based system, this would return at the third frame at 66 milliseconds. But in Silverlight's time-based model, you'll return at 132 milliseconds at the clock-based time, OK? So we evaluate, at that point in time, where should the animation be? So sometimes you'll see what we call a stutter. It will be smooth, and then something happens in the background. User code kicks in, or we're downloading something and creating a big visual tree. It will stop, and then it will reappear on the other side of the screen. And the way to actually watch for stuttering of animations is to keep an eye on what's happening on the UI thread. And we'll talk about profilers in a second. But the first key is that in Silverlight, we have one UI thread, and we depend on the UI thread of the browser to actually do all of our user code, control code, layout, and animations. So how many of you guys are targeting IE6 or IE7? How many UI threads are in IE6? 1. That's for the entire process. So that means that if there's multiple plugins or multiple tabs, I believe on IE7, somebody should confirm, that it's one process, one UI thread for all the tabs. So sometimes your application can stutter because there's other things going on or other things are visible. Off thread, we have the frame rasterization, so the stitching together of the final scene, and the media decoding. And of course, everything that is relegated to the GPU is also semi-off thread. It is dependent, however, on our tick loop, on our draw loop. How many of you guys have seen this diagram before? OK. So what this loop does is it's what happens every 33 milliseconds. We say a timer goes off, and it says, oh, 33 milliseconds have passed. Silverlight, has anything, are you free now? And it says, oh, yeah, I'm free. Nothing's going on. And it says, OK, are there any property changes? And so if there are any property changes, then we walk through the layout paths, and we figure out how big things are. We figure out how big the dirty regions are. And then we stitch together the scenes that need to be changed. And so this happens every 33 milliseconds if the UI thread is free. And you can change this, the frequency of how frequently we tick, with the max frame rate plugin counter, plugin setting. So like it's called max frame rate, and you can set it to 1,000, so it ticks every millisecond. And so basically, you have to think about this as a giant cog that's turning. We only get every 33 milliseconds to evaluate what changes happen. And of course, you can change it. And so generally, when creating changes into your application, let's say that you're changing the data template, the item template of your list box item, and you want to know if scrolling is a little bit slower if you have 3 buttons versus 2. I really honestly can't give you that answer. But you can give yourself that answer because you have the enabled frame rate counter. You can scroll with the change, and before the change and after the change, and evaluate the difference. And so again, this is a proactive version of your performance's health. You monitor your frame rate, you monitor your heartbeat while running. Okay, so I ache. And then you have to figure out, where do you ache? You have to visualize the pain point within the human body that actually hurts. In the same way, we're going to visualize the pain point of your Silverlight application, which is actually causing all the redraws. So there are two flags. How many of you guys have used enable redraw regions flag? Really? This is like, I mean, if I ask the graphics developers for anything, they're like, have you turned on enable redraw regions? And of course I have, because that's the premier diagnostic tool. It is so simple to use. So you basically turn on this flag, and it will show you what is getting painted, when and where. The reason why is because Silverlight only draws where it is dirty, right? So if you change like you have a whole, let's say like a tax form, and you have 100 different text blocks and only one changes, you should only redraw that little square. But we do this as far as we can figure out, and sometimes we get it a little wrong. So if you have something like a physics engine and it's changing things from like on a granular basis, sometimes you'll see things with gestures, and they'll slowly dissipate out the effect. And so it's eventually changing 12 to 12.001 to 12.002. Silverlight just keeps on drawing. It's like, hey, maybe some user can see that. So you want to always double check and make sure that you're not triggering more draws than necessary. And so I'll show you a quick demo of how this flag works. So the flag is called enable redraw regions. You can go to application.current.host.settings.enable redraw regions, or you can just search it and it will show up. So the application basically does this. You can tell how simple it is. It's just animating an ellipse back and forth. So if I turn on enable redraw regions, you already see the first thing. If I mouse over on a checkbox, we're tinting every frame in a different color. And so therefore, you can see how frequently things are getting drawn. OK. So if I turn on the redraw regions and I animate the ellipse, you can see that Silverlight is correctly only drawing the areas that have changed. It's drawing where the circle was and now replacing it with where the circle will be. Very simple flag. Expression Blend came out with a couple of different controls, which you can use in today's applications. And one of them is a carousel control. And it's a pretty awesome control. I didn't write it, so you can give them all kudos. You can actually plug this into your own application it's a lot smoother if you don't have a weird trackpad like I do. But there's sort of a gestures algorithm that's attached to this. Based on the velocity of my mouse and how far I've spun it, the wall 3D, this carousel will spin. Now, again, it sort of has an algorithm behind. And when we first got this application, it had very high CPU. And what we noticed was it was too sensitive to changes. So we fixed it in recent builds. Blend fixed it. But you can still, sorry, bad demo. OK. You can still see that it's still drawing a little bit after a user can perceive anything. You can also, with enable redraw regions, sort of watch exactly how the application is split up. You can see that this component was drawn in like maybe, let's say, 6 different rectangles. And that's how they actually compose the scene. So again, if you have something like, whether it be a physics engine or media, or you have text that's data bound and you want to know how frequently we're redrawing, you don't know if the data binding is being triggered on every frame, turn on enable redraw regions and you can simply see how frequently your text is getting rasterized. OK, so that's our second tool. Now we're at the systems level. OK, so we've done our frame rate, and now we've, I forget what the other one is. Oh, visualize the pain points. So now we want to sort of see how the systems work together. And this is something that was recently enabled with Silverlight 4. So the CLR team enabled an API so that the Visual Studio Team Suite profiler, aka F1, can actually trigger in and see what code is executing in Silverlight at any point in time. And it's a CPU sampler. So what that means is there's a timer flag on it. And so every time the timer goes off, and I think it's like the default is maybe 10 milliseconds or 100 milliseconds, it will just basically say, hey, what's the call stack now? OK, what's the call stack now? But it does it a little faster than that. And so what you can see is basically how much time is spent in your code, when and where. And so I'm going to show a demo of this. I will caveat and say that we haven't successfully gotten the symbols to work publicly. And that might be because the symbol server didn't propagate until yesterday. I will post instructions on my blog on how you guys, too, can get this to work. I know for sure that it works on my machine, though. OK, so let's close this. Close this. I just want to close this. OK. Yes. You're seeing the end result. Hold on one second. OK. So what we're going to do is we're going to run this application, which I wrote myself. And it's very ugly, but that's OK. What I wanted to do was, a common question is, how fast is it? I know it's faster to create the path geometry in the mini language, but for some reason, my application code requires me to create it with the managed code line segments and the path segments and to dynamically create it. What's the real difference? Now, the real difference depends on how complex your XAML is. And so what I did was I created a path geometry. And don't laugh, but I had converted this from an Excel sheet, and it didn't look like the conversion was too good. It's a map or a graph of the sunrise times in Seattle. The conversion didn't work out too well. There's a little peak for some reason, but don't worry about that. So on the left, when I click on that button, we do the XAML. We load with the XAML reader. So I take a path, and then I load it via data with 360 segments that are created in the mini language. And then on the right, I create the exact same path geometry, but I'm doing it on via managed code and by basically creating the entire visual tree for all the path segments. And the real difference here behind the scenes in Silverlight is that when you do the data mini language, the native parser kicks in, and we just load it into a binary format. We never create the entire visual tree for all the path segments. If you create it explicitly, then Silverlight will actually create the entire visual tree in case you want to animate any subsection of it. And you can see that both of them are pretty instantaneous. If I basically do the same thing 500 times, so I'm basically regenerating the geometry 500 times, you can actually see that there's a significant more difference. So one way to profile this is simply by doing timestamps. But the other way is to actually take a profile. So we're going to close this. How many of you guys have used the Visual Studio Team Suite profiler before? OK, yeah, a fair number of you guys. So we're going to use the command line. And basically, the first thing that I'm going to do is set my perf environment. Actually, I want to show you what my path is set at. So right now, my path has right here. No, right here. I have loaded into my path the Team Tool, Visual Studio 2010 Team Tools performance into my path. So when I set VLS perf CLR env, that's coming from that folder. So when we turn these environment variables on, it turns on the desktop environment variables. And what we want to do is set them for the Silverlight CLR. And Silverlight CLR is called core CLR. And so I'm going to paste those two in there. And so basically, I'm setting the GUID of the core CLR profiler to be the same that we would use for the desktop. And now I'm going to actually trigger my profile, and it's going to output into myprofile.vsp. And if I wanted to here, I could also set a timer and, oh no, I do it in the next one. Ignore that, Control C. Okay. So now I'm going to actually launch my process. You can either attach to a process or you can just launch it directly from the command line. And notice that I'm actually setting the timer here. Okay, so IE starts up and we launch the application. It's a little bit slower because we're taking CPU samples every frame. And what we want to do is sort of run that. And you generally want to do it a couple of times. And then we close it. And we'll just shut down. OK. So now I've created a profile with the CPU samples of what happens when I do xaml-reader.load. And then we want to do the same thing. We're just going to call it something else. We're going to call it explicit path segments. We want to take a different profile of the same application, but using the other button. It's thinking. Did I navigate? I did navigate. Something's not going well. It's OK. Don't worry about it. So normally, both applications would work, and the beta code would not arbitrarily kink out on me. Don't worry about that. It's all live code. OK. And then we're going to shut down the profiler. But don't worry, I have some saved profiles. So what I'm going to show you is simply this is a profile of if we did the explicit path segments in managed code. You have the summary of what's going on here. Generally, you have the startup here, and then the rest of the button clicks. And note, this is the time where I did it 500 rounds. That was my pre-saved profile. And then I'm going to click Show All the Code. And I've already set my symbols server. So my symbols path is local, but for you guys, it would be the Microsoft symbol service. And you can actually set it here in the debugging folder. Nope, there. OK, so Microsoft symbol servers. Sorry, I pointed right here. You would just click this, and that would actually, it probably should already be clicked, but it would actually call into the symbols path that Microsoft hosts and tell you the call stack for on the Silverlight side. So I'm basically going to the call tree, and I'm actually asking it to expand the hot path. Let's see. Oh, here, I've already opened it. And so what we see here is basically the profile will basically just walk through and show you the hot path of where the most time is being spent. I'm calculating it by inclusive samples. So that means that in the button click method, or let's mouse down here. OK. In the button click path, it is calling other code paths that will take up a total of 626 of the samples that were taken explicitly just for responding to that button click. And so in a comparison, if you wanted to compare this to the XAML reader, you can actually go back to Analyze, and you can open the two profiles, the baseline being the explicit code path, and the comparison being with the XAML reader code path. And you can actually create and generate a comparison report of what the profile looks with and without XAML Reader. And so what you see is that we're spending a lot less time in button click because we're actually spending a lot less time in creating geometries explicitly. Instead, Silverlight's just loading it as a binary. Now, the takeaway here, this is a really explicit demo, but in terms of, not explicit in the adult way, but explicit in terms of making sure that you can see a difference. For your code, lots of people ask questions like, hey, I can either create my control with visual states of like 3 elements and 100 visual states, or I could have 20 items and 30 visual states for a very complex control. And which one is faster? And like, honestly, the only way to tell which one would be faster, whether more visual states or more elements, is by comparing them and by running it. And then checking out your startup and seeing explicitly how much difference in time is spent if you change your visual style in that way. So with Visual Studio Team Suite 2010, you can actually get explicit idea of how much time is spent in your user code and your managed code. That's the screenshot in case nothing worked. But sometimes you want to go a little bit step further, and that's to see what's happening behind the scenes in the Silverlight code. The Silverlight code is executed generally in the native code path, and you can take a step deeper, right? So we've seen how the systems work, and now you want to sort of measure the blood sugar level within the Silverlight application. And so you can do this of 2 ways. The first one is by VS 2010 for Silverlight 4 only. But the other way is to actually use Silverlight, you can use xperf, which comes from the Windows Performance Toolkit. You can install that, and you can actually use it on Silverlight 3, Silverlight 1, it doesn't matter. The way that xperf works, which is released by the Windows team, is basically it uses ETW, event tracing for Windows, which is a logging mechanism, both at the kernel level and the user level, of what's going on behind the scenes. So again, it's just walking through and saying, hey, what's the call stack? And there are instructions that I've already posted on my blog about a year ago, and you can actually just search xperf and find it there. So, okay. So, no, go away. Okay. So we want to find out what the difference is if I employ the GPU in my listbox application. I'll show you guys how to employ the GPU later. But let's see what the difference is if it was. What's the win? Let me sort of give you some bait. So in software, this is the application. Seems to be scrolling pretty smoothly. If I open up Task Manager, it shows me basically nothing. It gives me not a whole lot of information. It says, oh no, I don't know why it's not staying up. It's okay. So Task Manager actually won't give a whole lot of information. If I went and switched it to hardware, I can scroll a bunch, and I'm getting, again, 60 frames per second, but I can't really tell what the difference was in the CPU before and after. So what instead we can do is turn on xperf, and so I've installed it in this folder here. So the first step is to set the NT symbol path. Mine is already set to local share. You guys will be using this Microsoft symbol server. Just I don't have network connectivity right now. And you can also cache it locally if that comes to the case. And so what we're going to do is basically profile with software and then profile with hardware. And remember how I said that I could attach to an existing process in Visual Studio? The great thing about attaching to an existing process is that you don't include the startup time. So, and startup time often is a very different profile than running. So I have already loaded up my application. I'm going to turn on globally the XPerf tool. I'm going to scroll. Oh, go away. And then I'm going to shut it down. So now what it's doing is it's turning off the profiler, which is a global level. It's figuring out what's going on in Visual Studio and in my IE right now. And then it's also merging it out into an event tracing log. And then I would repeat that for listbox in hardware. And the good thing is we already have these profiles. So we'll let that wait for a while. It's figuring out the symbol server. So a lot of times, time will be taken to go figure out what's correlating with the GUIDs with back into your symbols and what method is getting called when and where. So my profiles basically show this. This is the exact same application. I just ran the profiles earlier. It shows me that in the IE EXT, there's 25% of the time is being taken of all of the total CPU on software on the left, and on the right is hardware. In hardware, IE is taking 11.38% CPU, so pretty good improvement. AG core has gone down. AG core stands for silver core, AG, right? I don't remember what the Latin name for silver is. And we go down from 18% back down to 5%. So Silverlight is doing a whole lot less work in rasterization. And the reason why is because if you switch the list box to use the GPU, then every time that we do a pixel scroll, we're not actually re-rasterizing the text and figuring out what the best resolution of that text is at that pixel location. So there is an improvement, a significant improvement of around half of the CPU, but at the same time, maybe your text would not look as pretty. There's actually, sorry, just quickly, I will totally acknowledge this. Our text in the hardware accelerated pipeline right now has a bug on it. So you can see that it looks a little bit cruddier. That will get fixed. OK. So now we basically have, I think, 4 or 5 different tools to actually measure your frame rate, measure where is getting drawn, when and where with enable redraw regions. And we have 2 different profilers, one for user code and managed code, all the way down to your native code, and then another one that's available from Silverlight 1 through Silverlight 4 that's publicly available and free off of the Windows Performance Toolkit. I had a thought, but we'll return it to it. So with that, you can actually measure and profile your application. Let's switch whatever, tasks, and switch to employing the GPU. So I showed how in Listbox you can actually leverage the GPU, but what does that really mean? So you can define software in a couple of different ways. When I mean software, I do not mean the clothing line that Microsoft sells. I actually mean that the software pipeline that Silverlight wrote in Silverlight 1, we wrote it in software simply because we wanted to ship our rasterizer everywhere. We wanted you to write it once and it to look the same everywhere. And so the way we did that was we didn't depend on any of the OS components. We just wrote our own rasterizer end to end. So that's why your path geometry looks exactly the same on Mac and Windows. And so then we wanted to, I want to give you an idea of how that rasterizer works. So you start off with rendering the children. So for every node in the tree, remember how I said that like layout will trigger a redraw? We first evaluate what the children look like, and then we slowly apply each of the properties on that element. So then comes opacity mask, opacity, clip, rectangular or non-rectangular, a render transform, layout offset, and parent node. And then in Silverlight 3, we introduced 2 other properties, perspective and effect. And they work a little bit differently. They're not just a simple rasterizer. They basically use an intermediate surface. So we render we render the pipeline all the way up to the effect into a bitmap. And then we take that bitmap and we send it to the pixel shader, or the .fx file that you've created. And we send that as a texture, and then you basically come out with, hey, it's a little bit blurrier, or it's tinted, what have you. The thing to note about perspective and effect, which is particular, is that when you use these two pipelines, we end up actually creating a bitmap the size of that element. And so there's an allocation there, and then there's also an extra a blit, a copy. And so it's pretty usable, but at the same time, it can be expensive. So use it wisely, those two properties. The third feature that actually uses the render to intermediate is, of course, writable bitmap, which is basically please render to a bitmap. And then the fourth feature is the GPU caching. So what we do with GPU caching is we render to the video card. And the strength of the video card is that it can take something like an image and do a couple of things very fast with it. It can blit it. This is a BLT. I couldn't think of a better example. You could do a scale transform, a rotate transform, translate transform, and blending. And you could also do a clip. You could do a whole lot of things on the GPU. But in Silverlight 3, we just introduced these 4 or 5 different features. So because we introduced only those 5 features, we didn't introduce perspective or effect, basically those features are cut off for that node if you want to use the hardware. The other thing about it is vector graphics are really awesome in that they scale very nicely. They don't alias. But we render all the children, all of the little vector graphics in that bear, and then we blit it into an image. And at that point, it's frozen. So if you're doing a scale transform or a render transform, we're treating it like an image at that point. And that's why the GPU is doing a whole lot less work, is because we're just giving it less to do, less to rasterize. Now, the key note when you're thinking about hardware versus software is that you can't switch horses midstream. So you either go on the CPU pipeline or on the GPU pipeline. And if you use something like a perspective, a non-rectangular clip, or an opacity mask, then you're definitely going to be going onto the CPU. There's a software fallback path. So that's one thing to debug. And I have an entire Visio diagram of how to debug your hardware pipeline, but won't go through it. Just want to give you that understanding as to why. The other thing is that we did a little bit of a trick. We moved effect on the software pipeline because there's no opacity mask any longer. We moved it to the very beginning. And we can do this because it actually renders pretty much the same way. And the effect is done on the CPU, but it doesn't mean that you're necessarily getting software fallback. So to turn on hardware acceleration, 3 different tasks. The first one is to turn on enable GPU acceleration. We simply do this for stability. You have to turn it on explicitly. You need to set bitmap cache. You need to tell us which elements to render as an image. And then, of course, note that this hardware pipeline is only available on Windows in the browser in full screen, but it's also available only on the Mac in full screen. And that was largely due to rendering issues. So where do you set bitmap cache? Where do you identify what we should save as a bitmap? Generally, you want items that can be basically treated like images. So images are very good examples of this. Another one would be something where you have static content like that bear, and you're not doing anything with the insides. You're not moving the paws individually. So transform, opacity, and clip, those are all, if you're changing those properties rapidly, like on a list box, you're transforming it and then you're clipping it, you can actually consider that and send it to the GPU. And of course, again, make sure that you don't have any software-only pipeline on the self or the parent, so like perspective or effect. Because what that would mean is we'd have to take the bitmap from the GPU and send it back to the CPU pipeline, and that shift can be very expensive. So we just fall back to software there. And then, of course, you need to take care of your visual tree ordering. Now, this is a little bit hard to explain, so I did a little bit of PowerPoint fun. So let's say you have this wonderful little application, and it animates these little seahorses notice that the seahorses are static in the inside, but they're dynamic on the outside. So you're animating the translation, okay? And then you have this other random rasterization that's happening in the background. Let's say you have an effect, or you have Humpty Dumpty falling down. It's not something that is available to the GPU. So what do you cache? The first thing is, as soon as you create enable GPU acceleration, we create a bitmap for the background. Don't need to worry about that. The seahorse, which is not moving, is static, and so it's included in that intermediate surface. The two items that are dynamic that you're actually animating, you want to tell the GPU basically, hey, here's a little image. I've rendered the vector graphics into this image, and then here's some instructions on how to deal with it. So at this point in time, can you please render it at this location, and then blend it with the original scene. And then the third item on the top is dynamic and is not friendly for the hardware, so you just don't touch it, okay? So what your XAML looks like is basically this. And notice that the Z order is just going on the way down. You have your background, you have Humpty Dumpty, you have the seahorse that's not doing anything, and then at the two on the bottom, they're cached and they're actually moving. What your tree translates to is something like that. And again, you have the intermediate texture for everything in the background. And then you have the two cache nodes that you give to the GPU, and you say, here's the instructions on where to render. And then the GPU takes all three surfaces and blends them together and presents to the screen. And that's why it can do those blending, and it can do those translations a lot faster than the CPU. If you do something instead where you reorder Humpty Dumpty in between the two seahorses that are rendering, you have to note that you might create an intermediate surface in between. And I'm telling you this because it sometimes gets in the way of people. So we create the intermediate surface for the background. We have the cache node, the first seahorse. And then we create an intermediate texture for everything that's in between the first cache node and the second cache node. And it is the size of the plugin. Now, it's not terrible, but it's also, you don't want to do this too often. And then we give the GPU all four elements, and it blends it together. So when you're enabling GPU, take care to make sure that your visual tree is in an order that has the least amount of interleaving of cache nodes and uncached nodes. Always just sort of keep an eye on the frame rate counter. The frame rate counter in Silverlight, I'm going to have to skip this demo, but I just want to show out the frame rate counter quickly. The first one is your frame rate. The second one is the amount of video memory in megabytes. We have a bug in Silverlight 4 beta, which doesn't exist in Silverlight 3, and we'll fix again, where basically we're creating a lot of intermediate surfaces. So the video memory is a lot larger. And then the third element is the number of cache nodes, all the number of surfaces that we give to the hardware. So all 5 elements that we had in the last tree. And then the fourth number is the number of intermediate surfaces, the size of the surfaces that were created, the size of the plugin. So like the Humpty Dumpty one and the one in the background. So that's the fourth counter. So quickly, a more practical use of hardware besides, I was going to show you a demo with Calvin and Hobbes with a screensaver, is basically the media pipeline. And what the media pipeline does normally is it decodes the video at the frame rate, or at the size that you actually encoded it at. And then it does a YUV converter, luminance, chrominance, to the RGB values, the RGB language that Silverlight speaks. And then it does the resize and the blend, and then it draws. And in Silverlight 2, my advice was largely encode at the minimum frame rate, that still stands. And then the two things were encode at the desired size, and blending can be expensive. These are no longer so much of a concern in Silverlight because you can offload those two interactions to the GPU. So what you would do with your media player is basically create the background cover. It automatically gets created with enable GPU. You would cache the media element, and so when we decode and convert from YUV, we immediately give that back to the GPU. And then the GPU will do the sizing and the rescaling and blending with the top level stuff for you. And so that's all offloaded to the GPU. And you generally want to do this if your media element is stretching at all. And so if you have any sort of adaptive streaming pipeline where it's arbitrarily changing the size of the video that's being passed to the user based on what their network bandwidth is, definitely just turn on, give all of that stretching cost to the GPU. So simply, if you look at the Netflix pipeline, they basically have 3 surfaces, one for the background, and one for the media player, and then one for the player, the progress bar on top. So again, set all the different flags. There is another additional debugging flag called enable cache visualization. I'll talk about that in a second. And you can profile with xperf. And with xperf, I got these numbers. Just quickly, I basically halved the CPU for a 2004 laptop, so a really crappy old laptop. Without the cost of the decoding, without the cost of the stretch and the blending, that basically halved the cost of that media file. The less that you stretch, the less of the gain. So 360p versus 540p, there's less of a cost of there's less cost of a stretch. No matter what size you stretch it to, it's a constant cost. Okay, so media is a pretty good use of the GPU pipeline. Transitions, something like zooming in and out, minimizing and maximizing back out of a thumbnail. You can use the render at scale property so that it doesn't look gritty while you're doing that. And we can basically zoom in and zoom out as an image. Sliding, blending in, all those transitions. And then special uses of controls. So the list box from earlier, I knew that I could use hardware, but I know that we can't use hardware everywhere. The reason that we could use hardware in this control specifically was that we understood that the key concern was scrolling, okay? So with scrolling, we're generally clipping and translating. I knew exactly what was going on in my tree above and below it. I know that when I'm scrolling, the content is static. There's no mouse over effects, et cetera, happening. I also know that the parent doesn't have any effects or perspective anywhere above it. So this is not great for component vendors where they don't know what kind of application is going to host the control. This is very good when you know the entire application end to end. And again, I was using hardware-friendly properties. I was using clipping and translation of the stack panel. And I knew the explicit size. The reason why this is important is we can't create a GPU surface, or a surface on the GPU larger than the max texture size. On most of our dev boxes, that would be something like 4096 in any direction. On the average machine, though, it's more like 2048. So don't go past 2048, and you'll probably you'll be fine with hardware. So the advantage that I got was when I scroll, that's actually given back to the hardware, and then I have the amount of CPU used when I'm scrolling. The text is not recalculated every frame. So the text is treated like an image at that point, which is fast, but it also can be a little bit uglier. So you can switch back and forth between cache mode if you want the text to be back at the original look. So using and leveraging the hardware pipelines is very much like learning how to drive. The first few times can be a little dangerous, but afterwards, you get to be more of an expert, and you get to understand a little bit more how you can leverage the GPU when and where. So know the road. Watch the video memory usage. Make sure that you're not creating like 10 billion intermediates that are really large and really expensive to blit. I mentioned the bug earlier. Test with Silverlight 3, not Silverlight 4 beta. Watch your tree structure. Make sure that you're not interleaving or nesting cache nodes. And ensure that there's a positive impact. So sometimes a bitblit can be more expensive than just executing that transform on the CPU. This is the Visio diagram that I mentioned earlier. We're trying to simplify this, but simply, if you're trying to debug why some things are not getting hardware accelerated, this is the debugging diagram. So I'll give you that. That's on your PowerPoint, and it will also be on my blog, and you can find it and use it. Enable cache visualization is the other debug flag that I was talking about. You can turn that on, and it does a similar thing to enable redraw regions. It tints every surface that's in software, rendered in software, and it draws normally, in normal colors, everything that's in hardware. So use that flag for debugging, figuring out whether or not you're getting a hardware win. So, I am definitely out of time. Okay, I just want to quickly call out a couple of things before we go to Q&A. The first thing is effects and opacity masks, they can be expensive, and one of the largest reasons is because if you have a lot of content that is being applied into the effect and it's clipped, we're still applying the effect to the entire bitmap. And that's because an effect can actually take any sample at any point in the, it can sample at any point in the texture. And so we're doing the correct thing, but it can also be slow. So try to minimize the amount of content that you're sending to those four properties. Simple, basic stuff. Minimize the size of affected objects. So a blend with something that's transparent is still a blend of, is still a calculation or a no-op every pixel. We still figure it out. We minimize the number of operations that are happening. So if you're going to perspectivize 3 elements, why don't you just put it all on the same parent and then perspectivize that element? Of course, it depends on the design and the look that you're looking for. And of course, minimize the number of frames. So very good for physics engines, for instance. Just make sure that you're not drawing when the user can't detect it. So with great power comes, with great knowledge comes great power, rather. Try not to shoot yourself in the foot. We've given you a lot of tools so that you can actually access and debug your code. And your takeaway is largely try to be like the Prius. So how many of you guys have ridden in a Prius before? Yes. Okay, and what's the most disturbing about it? When it stops, what happens? Silent. The engine turns off, right? This also scares the crap out of bikers, too, because they don't know you're coming. And so I have a Prius, and the great thing about it, the reason why it's so fuel efficient is that when nothing's happening, when the user isn't going anywhere, it just turns off. And that's sort of like how your application should be. So make sure you're not using any of the CPU. I didn't cover too much of the graphics pipeline stack, but I've done it before in the Microsoft PDC 2008 and the mix. And then there's also a book. I think it's actually Essential Silverlight 3 now. But that's available in bookstores now. Ashraf is our graphics architect, and he answers all my questions about knowledge he gave you guys. OK, how many of you guys have done a survey thus far? OK, so every survey that each of you do, all those people that didn't raise their hand, you are taking $1 away from children, OK? So if you fill out the survey, it'll give me feedback. It'll give Microsoft PDC feedback on what talks you'd like to see or what content you'd like to see more of. PDC will give $1 back to Los Angeles Boys and Girls Club, so you can impact the city as well. And with that, I'll take some Q&A. So there are mics. If you need to take off for the next session, completely understand. But please use the mic for any Q&A. OK. Do we have any Qs? Questions? OK. We have one question, and then we'll probably call it a day. Sure. Yeah. Sure, so the question is, I have used enable cache visualization, but it doesn't seem to be working. So what's largely the interactions that you're seeing? Are you saying any tenting or none at all? OK, so the issue is that largely the application looks exactly the same when you turn on this flag. So the first thing is to make sure that you're getting hardware. And what I would do to test that is just to turn on the frame rate counter. Enable frame rate counter will tell you how much video memory is taken and also how many surfaces are getting created. And if you have surfaces that are getting created, then that means that they'll get tinted the color. If nothing's getting tinted, either A, everything's in hardware, and that's goodness, or B, you haven't even hit the hardware pipeline yet. So you want enable GPU acceleration, enable frame rate counter, and then enable cache visualization, all turned on to debug that. OK. Well, thank you very much for your time.
Oh, one more over here.
Oh, yes.
Hi. How's it going?
Oh, there's another one. Yeah.
Yeah.
Hi.
Hi. You talked a lot about the CPU today. I was wondering if you had any tips regarding memory consumption, or if all this goodness just comes from cache composition.
Yeah, so the concern is about memory consumption. I guess you heard that already. I didn't have to repeat that. And was it GPU related or not? It was just general visual trees.
Just general.
So I would largely map out with UI Spy to debug your memory usage and see how many controls are getting created. Anything that has a UI automation interface, so like any control from Silverlight will actually show up in UI Spy. And you can download UI Spy from the Windows Vista SDK. It's not available yet on Win 7, but you can download that tool. Just search UI Spy. I understand that there's also a need for memory profilers, right? And we're working on that. We don't have any answers just yet. So we got the CPU profilers, baby steps.
Right.
OK.